Chapter 7 is called the derivative. In this chapter, you're going to be introduced to an aspect of mathematics called the calculus of mathematics, which actually has two branches, as you can see here. The chapter 7 focuses on differentiation. There is this other branch, which we will come to a little bit later. The significance of calculus is demonstrated in this course in that almost every chapter that you do from here on has an element of calculus in it. So it's really important that you understand what this process is doing, as well as you understand how to do the process. So let's get started. The derivative focuses on gradient. Now, there's nothing new about gradient. However, your previous study of gradient has only involved finding the gradient of straight lines. We're now going to move into looking at the gradient on functions that are not straight, or graphs that are not straight. So you can see here a parabola, and we're going to talk about the gradient. You can see here possibly the cos graph, and we're going to talk about its gradient. Clearly the gradients are changing, as you can see from the slope of this red line, as we move along the graph. So the gradient's actually changing, which is a significant difference between the gradient of the previous functions that you've studied. You've only looked at the gradient of a straight function, straight line graph. You may be wondering at this stage why we need to study the gradients. Well, it won't become obvious why until we start the applications of differentiation. But for engineers, scientists, the gradient is an extremely powerful and useful calculation for them. It tells them many, many things. When they're investigating speeds, pressure, time, the gradient it's critical that they can work out the gradient. So for now, we're not focusing on the application, but the application is by far the more interesting part. For now, you just have to learn the process. How do you differentiate? And what you'll find is that there's no one rule for differentiating, unlike with the straight line. With the straight line, we had rise over run. However, the nice thing is that the gradient for these other functions is based on rise over run. In theory, it's based on rise over run. Although we're going to see that the gradient obviously changes. The gradient of this line, if I'm at this point here on the parabola, if I'm at that point, the gradient is very different to if I'm over here at this point, because if I was to draw a little tangent here, you can see the slope of that tangent should be touching. Has a positive slope, and over here the tangent has a negative slope. We say the gradient has a negative slope here and a positive slope there. And in fact, if on this graph, if I draw my tangent here, I say that the gradient at this point has zero slope. Now, all of those variations, zero slope, positive slope, negative slope, give engineers, scientists, etc., mathematicians, extremely important information. You're going to hear me frequently talk about or name this red line that you can see here. The red line is what we call a tangent. Its only function is to give us a visual idea of what is happening at a particular point on a curve. So this tangent, that's really its only function. You're often asked to get the equation of the tangent. However, initially, if you think about this red line as just being a visual representation of what is happening at a particular point. The definition of a tangent is a tangent touches at one point only. So it could touch a circle at one point only. Here it's touching a parabola at this point only. Over here, I think it's meant to be going through the origin. So it's touching the sine curve. Did I call that cos previously? It's touching the sine curve at this point, the origin only. And as you saw here, it's sometimes quite difficult to draw a tangent to make it actually look like it is touching at only one point. But by definition, that's the tangent. Doesn't have a significant role in the actual function. However, it does tell us about the gradient at a particular point. Now remember, we're focusing on gradient. We're really focusing on gradient. So you'll hear me talk a lot about gradient, a lot about tangents. This is telling us a little bit more about the application that once we get into being able to differentiate and find the derivative, we could be calculating things like velocity, acceleration, resistance, pressure. So this is really about the application, which will come after we've mastered the technique of differentiating. And like we've said, we're going to focus on gradient. I'm sure you're familiar with a line has a positive gradient. You can see here our non-straight curves have sometimes positive gradient, sometimes negative gradient. Or you can see that they have a zero gradient. We could, and you saw me demonstrate that above, that if we draw a tangent and it's horizontal, then the function has zero gradient. We don't come across this situation very often. However, if our tangent was vertical, if there was a point on our graph at any stage where if we drew a tangent, the tangent was vertical, then it has undefined gradient. In fact, we can't differentiate at that point because there is no gradient, and differentiation is the gradient is undefined at that point. And if the gradient is undefined, then the derivative is also undefined. The derivative, the gradient can be zero, and that is not undefined. Zero is not undefined. And so we'll see the difference between these two. You saw me actually illustrate on the curve above that where the gradient is zero is often of particular interest. It tells us lots about, now in particular, if you can remember this, maximum velocity, minimum velocity, etc. Gradients of zero are usually connected to maximum points and minimum points. And like I said, there'll be a lot more on that as we move on to applications. I'm going to stop the video there and talk about the more practical ways of finding the gradient in another video, because it will involve a little bit of a lengthy sort of explanation. But for this video, I feel like I've rewinded if you're unsure of the actual purpose of finding the derivative. Listen to it as many times as needed, because it is really important that from the beginning you know, I guess, the theory behind finding the derivative.